So in the previous part of the lecture, we talked about expectation. So it would be only to be inferred from the static type of the variable. So keep that in mind, and we need that in order to do what we want to do right now. Okay, so in the slides, we said polymorphism intuition. I'd like to give you some intuitive idea about what polymorphism really is. So that's really about, it really boils down into expectation. So let's consider this simple example over here. Okay, so now let's talk about the same inheritance hierarchy. As we said before, you're very familiar with this particular example already. So let's talk about the following fragment of code. Let's say this. So we got S of static type students. We got RS of static type resident students. And then we are trying to do two creations over here. So we say we want to create S.make and then Stella. So now you can see we don't have the square bracket, the curly brackets. So that means the dynamic type for S will just be the same as its static type. So that means after this line over here, we're going to have S is now pointing to an objects at the runtime of type students. I'll say students over here. Okay, so what attributes do we have for student? What expectation do we have for the student? Think about it in your mind before, and then we need that in order to solve this exercise over here. Okay, and then when we go to the second line, for RS, again, we don't have the curly brackets, so that means the dynamic type is just the same as the static type, which is resident students. So that means RS is simply just pointing to another object dynamically over here of type resident student, just the same as a static type. That's why we don't have the curly brackets, RS over here. Okay, so now, and then we try to do something more. We say rs.set premium rates. Okay, so this one should be quite possible because in this one here, RS dynamically, it will be RS, resident students. And we know that a unique expectation for resident students, for example, one of them would be just the premium rates. So we can put a PR over here, just one of them. Okay, premium rates, and then we can have 1.25, just one of them. Whereas for the students, dynamically, we don't have the premium rates. Okay, so now here is the question for the exercise for you. Let's say we got line number 8 and line number 9, two potential lines. Can we say S is assigned to RS, or can we say RS is assigned to S? Are both valid? Are both invalid? Or one is valid but the other one is not? So that's the question for you. So that's question number 1. Which one should be valid or both? And number 2 for question number 2, why or why not for your answer? Pause the video and think about your answer before we go on to explain that. Okay, so hopefully you thought about the exercise and try to give your answer and also justification. This might be something you learned from the previous OOP course. Maybe you understood it completely, or maybe you simply memorized the rule. Either way, but let's try to understand that intuitively. Okay, so it turns out this line number 8 is valid, which means it will compile. On the other hand, this line over here will not compile, which means it is invalid. So now we want to know why. I would like to start with this one over here, which is invalid. Okay, how do we justify that? So I would like to do a little bit of proof over here. So you know about a proof technique called the proof by contradiction. So we assume something that we want to prove as false, initially assume that to be true, which means allowable assignments. And then we want to follow through certain steps, and then we can end up something that's actually false. In that case, that means our initial assumption must be false, which means that thing we assume to be true must be false. So that's the proof by contradiction very quickly. Okay, let's see how we can do this. So I will simply do the following reasoning. So I would say assume RS is assigned to S compiled. And if by following this particular assumption over here, if we ended up something that's disastrous, that's false, or simply crashing, So that means our initial assumption that it should compile should be false. So it shouldn't compile. That's kind of the logic that we want to follow through. Okay, let's see this. So we assume that RS is assigned to S is simply will simply compile. So that means we're going to execute this particular reassignments. So that means at a runtime, we're going to execute the reassignments. Execute the reassignments. And how do we execute these reassignments? So that means RS is now going to store the address that is stored in S, right? Or diagrammatically, RS is going to change its pointer over here, and RS is going to point to wherever S is pointing to. So RS is pointing to just the same student object over here. So that's aliasing. Okay, so that's how we execute at runtime, assuming that the line is going to compile. Okay, so far so good. So now, how can we actually know this will lead to something crashing or something that's false? How do we know? It has to do with expectation. Okay, so now what would be the expectation for RS? Okay, so now here's a question. What is the expectation on RS? Well, as we learned previously, in order to figure out the expectation, you have to only look at the static type, right? That's what we knew from the previous exercise over here. So now, let's be precise over here. What's the expectation for RS? Well, it depends on its static type. Okay, let's write it down. So RS static type, which is resident students. And for resident student here, expectation, there are two parts. So we got the name, the courses, the register, and also the tuition. So these attributes these features are simply inherited from the student class. And also we got a unique expectation for resident students. Let me put it down as well. So that'll be the premium rates and also the set premium rates. So that would be also the premium rates and set premium rates. So these are the expectation, right? So these this collection over here. So this is something you knew already from the previous exercise over here. So now, being expectation simply means we can say RS dot, right? That's what we meant. So now let's try this. So now if we say, let's try one of them. Okay, so I'm just running out of space, so I'm going to put it here. Okay, so now following this, so now if we say RS dot PR, for example, if I say RS dot PR, what's going to happen over here? You can see RS right now dynamically is really pointing to just a student objects. Can student objects support premium rates? The answer is no, because if you look at the student class over here, so this is really just about visualizing your objects at the runtime. So now for any class, you can only support the attributes that's actually declared, or even in our inheritance context. For example, resident students object at the runtime is going to support all the attributes, not only in the current class, but also whatever that's inherited from its parent class. But now we talk about student objects. For student objects, it's going to be name, courses, the attributes, right? So it's going to be name and also courses, right? And of course, it's Stella in this case. I just omit that detail here. So now only name and courses will be supported by the student object at the runtime. But now if we say rs.pr, what's going to happen? Well, it's going to crash because there's no such attributes. So now what's going to happen is it's going to crash because not supported by the student's objects. Okay, you can see by making this initial assumption, what we get is a crash as the result. So that means our initial assumption must be the opposite to the truth. So that means this particular line should not compile. So hopefully you can see the logic over here. So I'm trying to show you this intuition here because you shouldn't really memorize the rule about how to really do the reassignments, which we'll show you the rule in the in a later video. But to really work out the logic yourself, this is the best way to think about it. Okay, so now let me just make the conclusion here. So now, given that we're going to get crash over here, so this let me just draw a little bit better. So the crash over here, so this is something we want to avoid. So that means this false consequence tells us this initial assumption here must be the opposite to the truth. Okay, so now let me just box it over here. Okay, so now the opposite should be true. Which means RS is assigned to S should not compile. Okay, so that's about how to explain why line number 9 is not going to compile. So now it's very easy and very straightforward to actually explain why line number 8 will actually compile. Let me sketch the idea and then you can see the more detailed description on the slides. The reason that this will compile is because, so now if I say S is now assigned to RS, so that means S, rather than pointing to this object over here, S is now going to point to this particular object over here. And then, are we going to run into any crash? The answer is no, because the expectation for S is determined by its static type, which is students. And now, what can we call on the students? We can call name, courses, and register and tuition. And all these attributes will be available to RS objects at the runtime because RS simply inherits all the features from its parent class, which is students. So it's guaranteed. So even though you actually got PR over here, but it will just never be called. It's just not part of the expectation for S. Okay, so this is why this line will actually compile. Okay, you can look at the slides more carefully. Okay, hopefully this little proof over here really help you understand whenever you do assignments, should you go one way or the other? So this is how you can work out the logic. Think about the consequence of making one assignment to see if that will lead to a crash. If it would, so that shouldn't compile in the first place. Okay, if you go back to the slides, you will see that's exactly the way I try to argue in the iPad. You can read them through again if you prefer the written form. Okay, so that's about this example here. Okay, so this is about why it is valid. Okay, and notice one thing. So when you actually do S is assigned to RS, notice that so you cannot really say S dot set premium rates, even though at the runtime it's really pointing to a resident students object. Remember, we said the only thing you can use dot should be within the expectation of the static type for the variable. In this case, S is of type students. In that case, set premium rate is definitely not part of its expectation. Okay, just remember that. Okay, so the second intuition I would like to give to you is about dynamic binding, which is closely related to the polymorphism that we just talked about. Again, I want to give you some intuition about the formal typing rule. I will talk about it maybe a little bit later in the lecture. Okay, so let me switch to iPad and talk about this example over here. We're using the same students inheritance hierarchy, just the same as before. Okay, let's take a look at what we have right now. So we have a C of type course, and also S statically of type students, and also RS statically of type RS, resident students, and RS statically of type non-resident students. Okay, so that's a setup. So you should really think in your mind what would be the expectation between S, RS, and NRS. Remember the table that we filled in before. Okay, so what we will do is we'll first of all create a course called C over here. So you can see the C is really pointing to a course 3311 and also let's say $100, right? That's exactly the object we're creating over here. Okay, let's go on. And then let's say the next line we want to talk about over here. So here we say creates rs.make. And now for simplicity, we simply say rs. We can see the static type is simply resident students, and the dynamic type will simply put it to be the same. So later on, we'll make it a little bit more general by saying what can really appear to be the valid dynamic type that we can put here. But let's not complicate the matter just yet. Okay, for now we'll just put it the same. So the same will just be valid. Okay, so now let's say rs is now rs statically will be resident students, but now dynamically is also pointing to a resident students objects. Okay, and similarly, we're also trying to create another objects over here. NRS is now going to be having dynamic type just the same as its static type over here, just the same for simplicity. So that means NRS is now having the static type, always the case, but now it's having this dynamic type over here. It's pointing to there. Okay, so that's a setup. And we do a little bit of housekeeping stuff over here by saying RS does set premium rate to be 1.25. So RS does set premium rate to be 1.25. And also RS does register C. So we kind of talked about how we can execute these commands before. So I'm going to omit the details. So register C. So that means for RS, this particular resident students, they are going to have their first course being 3311. And then we are also going to say NRS does set discount rate to be 0.75. So NRS, and then we set its discount rate to be 0.75. And then we're also going to register that student to the same course. You can see the course linked list will be also pointing to its first element to 3311. Okay, so far so good. So that's only the setup, the scaffolding. But now let's see how we can understand about dynamic type. So I want you to consider two assignments over here. Number one, S is assigned to RS. This is something we said before that you can do. You can now try to do a little bit of proof in your mind. We say that S is assigned to RS will just be okay because later on, when we try to call any expected feature on S, that will be guaranteed to be supported on RS. However, the other way around will not be valid. If we simply say RS is assigned to S, in that case, some expectation on RS, for example, RS.PR, premium rates, cannot be supported by the object that's pointing by S, possibly, right? Let's say S is pointing to a student object, right? That's kind of the logic that we talked about previously. But for now, we know that S is assigned to RS. This will be okay. Okay, and also later on we also try to do something similar. We say S is assigned to NRS. So now whenever you're trying to reassign variables in the context of inheritance, you're basically changing the dynamic type. That's basically what you're doing. So let's do one by one. For number one over here, when you say S is assigned to RS, so S right now is now going to point to wherever RS is pointing to. So this will be number one. After number one over here, you can think about this resident student over here is the dynamic type. Dynamic type of S at this point. It might change later. So now when you see S.tuition, so now when you see S.tuition, what should it be? Remember we said before, let me just remind you very quickly. Remember this not here. Remember this diagram over here that we talked about in the very beginning of the lecture. So there are three versions of the tuition. Version number one, version number two, and also version number three. So now, which version is going to be called? So which version that will be called at the runtime does not depend on the static type. It depends on the dynamic type. That's why it's a runtime phenomenon. Okay, let me just go back there about this. Okay, if I go back here, so now if I say S.tuition at this point in time, S dynamic type is, because it's now pointing to resident students, is RS. So that means version number two, you can look it up, version number two of tuition in resident students is actually called. So now every time you want to know which version of the routine or feature is actually called at the runtime, you have to trace about the dynamic type for that object at that particular execution point. Okay, so now so that means version number two. And version number two, let me just tell you, version number two is simply just going to go together with the premium rates, which will be 1.25. So that will be 100 times 1.25. So it should not be surprising to you. Let me just change this. It should not be surprising to you. It will just be 125. Okay, so hopefully that makes sense to you. Okay, let's do another one. Let me do pink. So now the second one I want to do is just another reassignment over here. So now S is reassigned to NRS. You can do the similar proof because every expectation that's on S statically name, like a name, register, courses, and etc. Right? All the expectation on the student class can all be supported by NRS objects. So this will be number two. If we do number two, so that means this link So S, rather than pointing to over here, S is now going to point to this object wherever NRS is pointing to. So after we have done this, so now that means non-resident students now has become the dynamic type of S at this point. So that will be the dynamic type of S. So now if we say S dot tuition, notice one thing here. I want to be very precise here. You see S dot tuition identical to S dot tuition. However, are we going to have the same behavior? The answer is no, because the runtime behavior depends on dynamic type. So now to be more precise, you can see S at this point over here, S dynamic type is, because it's currently pointing to non-resident student, so that'll be NRS. So which version will be called? That implies it will be version number 3 over here, version number 3 using the discount rate. So version number 3 of tuition in NRS is called. In that case, we're going to apply for the discount rate 0.75. So now, if you, for the same course that's cost $100, so that'll be $75 over here. Okay, so now take-home message for the intuition for dynamic binding. If you want to argue about the runtime behavior, you have to trace about whether the object right now is really pointing to either this object dynamically or this object dynamically. Because at different points of execution, you might have just different result, even though statically these two lines look just identical, but dynamically it might just print out different result. So that's the essence for dynamic binding. Okay, so now in this video, we really talk about the intuition between polymorphism and also dynamic binding. Review the results very carefully, make sure you really gain the intuition before you move on to the next video where we're trying to get things a little bit more formal.